And a little bit of background about myself. So I'm a project manager at BITSS. My work here focuses on transparency norms and policies in journals and research organizations, among other things. And my academic background is in law and in public policy. So just to get situated in the RT2 roadmap, the first part dealing with the social science reproduction platform will be targeting these few elements of the RT2 roadmap, which are related to computational reproducibility. And then the second part, circled here in blue, will be focusing on the social science reproduction prediction platform, which falls mostly in early on in the RT2 roadmap in the research design stage. So before we delve any deeper into each of these platforms, I want to tell you about what they do and why we built them. So the social science reproduction platform, or the SSRP, serves the purpose of crowdsourcing and cataloging attempts to assess and improve the computational reproducibility of published research, whereas the prediction platform serves the purpose of streamlining the collection and the act of contributing predictions to social science research results. And the joint motivation behind both of these is to kind of open up various black boxes in the research cycle, or to demystify, make explicit various parts that are otherwise implicit or tacit. Specifically, the SSRP does this by opening up the data code and the methods for analysis. So all of the scholarship work that precedes a typical research paper. And then the prediction platform makes explicit expert priors and knowledge. Additional motivation for the reproduction platform specifically is to accelerate the computational reproducibility of published work. And just to define the terms here, by computational reproducibility, we mean the ability to obtain results which are consistent with what's in the manuscript, using the same data, same methods, and the same conditions of analysis. Or also, we call this process push-button replication. You might have heard that term used instead. And then the process is called reproduction, and the authors or the actors, the protagonists of the process are called reproducers. This is not to be confused with replicability, which is based on using different data or different methods or both. So computational reproducibility is essentially the backbone of good science. It is necessary for scientific credibility. It effectively puts into practice the Mertonian principle of organized skepticism that we talked about on day one. However, despite this benefits, despite this value, it is surprisingly difficult to reproduce published work in the social sciences. And here I'm just going to list the results of several large-scale reproductions of work in the social sciences, so starting from economics to evaluations in health and development, macroeconomic psychology, etc. And you can see the success rates across all of these are relatively low, ranging from 40 to 36%. So we try to address this by through this platform by the virtue of crowdsourcing, or conducting reproductions of work at scale. So the platform itself serves beyond just simply serving the purpose of recording and crowdsourcing reproductions. It also allows its users to collaborate and to review each other's work. So we host an online discussion forum, which is moderated, where people can share their work and then contribute feedback. And then finally, we will also aggregate all the data that gets inputted from users into a reproducibility dashboard, which will provide descriptive statistics about the reproducibility of various disciplines, bodies of literature, and even journals. The platform's intended users are primarily students and instructors in applied social science courses. It is very common, I think, to use in social science courses replication assignments, which involve reproducing work that is published. And this is a good teaching tool to introduce students both to methods and then fundamental concepts in the social sciences. Beyond students and instructors, other target users are researchers themselves who are interested in auditing the reproducibility of their own work or other people's work, and meta researchers who might be interested in doing research with the reproducibility metrics. So SSRP reproductions have several distinguishing features which make this platform different from some other similar related efforts. And the first one is standardization. So the work on the platform gets inputted through a guided standardized survey, which is based on 5 stages. So going from, and it leads users from selecting a paper through scoping the paper, so identifying its main components, and I'm going to talk about this in a little bit. Assessing the reproducibility, so rerunning everything and then assigning a score of reproducibility, then implementing any improvements to improve the current reproducibility, and then you can also conduct robustness checks. In concert with the platform, we provide this guide for accelerating computational reproducibility, or we also call it the ACRE guide, which is kind of like a protocol for how to conduct reproductions. But it also includes resources for how to use the platform for teaching purposes. And also we provide guidance on how to communicate constructively with the original authors in cases when reproducers need to, for example, ask for data from the original authors. Another key feature of SSRP reproductions is our nuanced approach to assessment of reproducibility. So it's not that uncommon, unfortunately, for discussions around reproducibility to evolve around binary judgments, which declare entire bodies of literature or entire papers as reproducible or not. So we're trying to steer away from that approach, and instead we break down papers into their main components, including research claims. So every paper may have one or more research claims, and these are kind of like the main findings, which are typically highlighted in the abstract. And then the findings of the display of these research claims are usually showcased in display items, which are tables, figures, and other inline results. And then it's important to highlight that different display items can be reproducible at different levels. And reproducers can there are specific steps that reproducers can take to bring the reproducibility of a specific display item from one level to a higher level. And speaking of levels, we apply universal assessment criteria when assessing reproducibility. So we've developed this 10-point scale, which grades the reproducibility of display items based on the availability of data, code, and the ability to reproduce the results consistently with what's in the manuscript. It moves from, as I said, from level 1, which includes no materials. So a display item where no data, no code is available will be at level 1. Level 5, which entails reproducibility from analysis data. So these are the data that have been processed and been cleaned, prepared, so in order to produce the final result. And then level 10 is being able to reproduce from raw data, which is kind of like the golden standard for reproducibility. And then importantly, as Lars was talking in his previous talk, there are instances where data can't be shared, such as administrative data. So this scale is adjusted for such instances. And the emphasis is instead on detailed documentation for how to access the data. And then also you can provide certification from an independent reproducer that was certifying that they were able to reproduce the data. So without further ado, let's see what the platform actually looks like. Now let's see if I can do this right. You should be able to see my other screen. Can you see that?
No, not yet. We only see
Okay.
your slide.
Okay, let's try this. Okay, so this is the platform. You can visit it at socialsciencereproduction.org. From the search bar, you can see all the reproductions that have been logged on so far. So today, we're just going to focus on this paper called Gender Bias Among Professionals by Alice Wu. As we can see, there's 4 reproductions that have been logged on so far, varying in scope. Let's choose this first one. So this is what we call the reproduction report on the platform. So this is kind of like, this summarizes the results of the entire reproduction in quite a bit detail, as I'll show you. Up here, we have basic information about the reproduction. So the author, when it was created, the number of claims and display items that they assessed, whether they ran any robustness checks, whether they made any improvements, and then also links to the reproduction packages, both the one that was provided by the original author, and then also the one that was developed by the reproducer themselves. So by reproduction package, we mean the location where they store the data code and other materials for that are required for reproducing the work. So starting from selecting a paper, you can just input the DOI here, and the platform automatically populates the rest of the metadata. You also record the reproduction package. At the scoping stage, so here you first summarize the paper. So this is just to demonstrate clear understanding of the paper. And then you outline the claims. So as I said, these are kind of like the big findings of the paper. And this is subjective, but it helps with understanding the paper and like also planning the exercise itself. So for example, this person will only focus on one claim. And then you can also declare robustness checks that you'll conduct later on in the reproduction. At the assessment stage, which is kind of like the central part, first we delve into the reproduction package. So looking at all the raw data and the data files and the data sources, so cataloging everything, also cataloging all the code scripts. And as you can see, this is pretty detailed. This is pretty granular. The idea here is that first, reproducers demonstrate their understanding of the reproduction package, but then it also allows for other people to take up their work and upgrade it. So for example, reproduce the remainder of the paper. All this inputted files produce these, what we call reproducibility trees. So these are diagrams which visualize the contents of the reproduction package and how they're related to each other in order to produce this top level display item. In this case, it's an inline result. And then a central part of the assessment section is assigning a score. So what these objective assessment criteria that I was talking about earlier to the display, to every display item. So in this case, the reproducer found out that this item was reproducible at level 8. So all the materials were there. However, they had some problems executing the code. And in the next stage, at improvements, they were able to actually try to fix this. In this instance, they tried, but they weren't successful because the level of reproducibility didn't really change. They can also improve the reproducibility of the paper as a whole. So rewriting everything in an open source software, using version control, putting it in a computing capsule, etc. So this is what a reproduction actually looks like. Another key feature of the platform is the forum. So this is where people can share their work. Specifically in this section of the forum, we encourage people to share their reproductions and tag them with the DOIs of the paper. So for example, this person shared their reproduction of this paper, and other people can see it and chime in with their feedback. And or also help them upgrade the project. So that's kind of like the platform in a nutshell. I encourage you to sign up for your profile and test things out. And let's see, I'm going to try to navigate back to my slides. So if this is something that you'd be interested in, here's how you can get involved. First of all, you can start using the reproduction platform in your classroom. As I said, the platform almost perfectly streamlines the process of using reproductions as class assignments. We've tested it out in multiple undergraduate graduate level courses, but also with undergraduate students. And we found out that they're able to pretty much use it independently. The lessons and the resources that we developed along the way you can find in the ACRE guide. There's a specific chapter which provides instructions and resources on how to use the platform for teaching purposes. You can also share your feedback or request a feature. So there's a form on the homepage of the platform where you can do this. And then finally, if you want to get involved, if you're very keen in working in computational reproducibility, we invite contributions to the ACRE guide and the platform itself if you're keen in coding. And of course, we will recognize your efforts and add you as a contributor. So that's kind of like the first part of my talk. In the second part of the talk, I want to tell you a little bit about the other platform. So the Social Science Prediction Platform, which, as I said, is its intended use is to streamline the collection and the act of contributing predictions to social science research results. And predictions can be about all sorts of things. The most obvious one is results of experiments, so be it field, lab, or natural experiments. So, for example, right now there's a project that is collecting predictions on an information intervention targeted at improving the efficiency in public spending. You can also collect summary statistics. So there was a paper that closed out recently. That was a project that was collecting predictions of the publication trends of research on race in economics. You can do comparisons of competing treatments and just about any other project which is prospective. So early on in the research cycle. So why bother collecting forecasts? First of all, it helps us collecting forecasts systematically. It helps us understand how much we're learning from new results. So it is all too easy to speculate after the fact once you've seen the results, when there's hindsight bias. And forecasts, by collecting them early on and having clear accounts, we understand how much learning takes place with every new result. Collecting forecasts is also helpful to mitigate publication bias. So we all probably know that no results are quite tricky to publish because reviewers and editors sometimes say that they're not interesting, they're not surprising. So if you collected forecasts, you can compare the null result against the forecast and then show that, in fact, the result might have been actually unexpected. And then finally, collecting forecasts systematically is helpful for improving research designs. So over time, by collecting forecasts systematically, we can understand the defining features of what good forecasts are, which can in turn help us prioritize which treatments to select when there's multiple options, so to get most bang for your buck. Also, they're helpful for planning effect sizes, statistical power, and also for interpreting the results afterwards. So you can use the platform both as a researcher collecting predictions, but then also you can contribute predictions. If you're trying to collect predictions, this is kind of like the usual setup, the usual workflow. At the design research design stage, this is the best time to think about collecting forecasts. So because forecasts are the most helpful before the results are known. You can start building your survey in Qualtrics because the platform has perfect integration with Qualtrics. We have an API. And we also provide this forecasting survey guide, which is kind of like a collection of annotated surveys, templates, and tips for how to configure your survey in Qualtrics. And then you can also contact our support team, which are there to give you guidance, help you if you get stuck along the way. Then you can submit your survey. It undergoes review just to make sure that it looks good, it works as it should. Then you can move on to actually collecting forecasts, either by opening up the survey to the registered users of the platform. There's, I think, 2,100 registered users currently. Or you can also just bring in your distribution list and kind of like consciously share the result, the survey with your intended audience. And we will also help you distribute. We send out regular newsletters, reminders, and we post things on social media. Once you're done with collection of forecasts, we highly encourage you to upload the results back onto the platform. It's helpful both for the forecasters so that they can compare their predictions against the actual results, but then it's also good for transparency. And if you're keen on contributing forecasts, you can always go to Social Science Predictions, prediction.org/predict, and you'll see multiple open projects collecting forecasts at any time. The ones which are marked with $sign offer financial incentives. So if you contribute, you might get something in return outside of just bragging rights. And then after the data collection or forecast collection is done, you get to compare how you did against the average prediction and the actual results of the paper once the users upload the results back to the platform. So go to socialscienceprediction.org/predict and start predicting. And just to wrap up, so I'm just a messenger here. These are the teams that stand behind these projects. There's a bunch of other folks who are listed here. And if you're interested in learning more, my slides are on the OSF project, and here are some helpful links. And you can also come to my office hours, I think, in about next week.